Hello everyone. A very good morning, good afternoon and good evening to one and all present here. Welcome to Texila e-conference knowledge series. Thank you for joining today's webinar session. My name is Divya Bhupati and I am the SEO analyst at Texila e-conference. Texila e-conference is the leader in organizing online conferences and has been helping entrepreneurs, marketers and professionals achieve their goals. Texila e-conference, being an information hub, has networked 300 plus international speakers from top brands and shared abundant knowledge to people across the globe. It has hosted eWay conferences from 2014 and has inspired people to exchange information on virtual platform. I hope you all have enjoyed the last day session and gathered a lot of information about how to build real-world products using machine learning from Mr. Rudradeb. He shared the information about where can artificial intelligence add the most value, strength and weakness of human and machine intelligence, conditions for selecting a use case for intelligence products, and finally he explained on build a real-world products using machine with 5 steps and 3 cases, which is very useful and informative. Today, we are going to learn about how to overcome challenges with data product development and user adoption for your machine learning product, presented by Mr. Rudradeb Mitra. Rudradeb is a global entrepreneur, having built and scaled startups globally including US and UK. He is also a product mentor for Google Launchpad, MIT Enterprise and Founders Institute. He has been invited to speak at around 50 events from 15 countries. Recently, he published his first book on artificial intelligence titled Creating Value with Artificial Intelligence. Before we get started, I want to share a few operating instructions to all the participants. Participants, please check your audio settings to make sure the presentation is audible. If you have any questions during the presentation, please type them in the chat box. You can also click the raise hand button at the top so that the presenter will get an alert. Now, without further delay, we will join the session with Mr. Rudradeb Mitra. Hi Rudradeb. Once again, welcome to Texila e-conference knowledge series. It's a pleasure to have you here.
Thanks a lot. So, I hope some of you guys who listened yesterday I try to explain you guys at a very initial level or a basic level that what and how to solve problems using AI and machine learning in the real world. Because, and this is something I keep on seeing around the world, that there is a huge hype and people think that AI is a way tool to solve all problems in the world, which is far from truth. And there is a huge, and for whatever reasons of the hype, and everyone thinks that, okay, the next big thing is AI, and I want to study data science, and I want to be a data engineer. I also think that that's also a kind of, not going to be this true, like, that's not how things will be going ahead. And the key value of AI and machine learning, which I said yesterday, is solving real world problems. Otherwise, there is no value for a technology. Today, one of the challenges that most data scientists or data engineers face is when actually building the product is around the data and building the product, and user adoption and architecture. Now, that often they don't learn. So I kind of can stress this point more, that there is a huge interest among people to kind of learn the mathematics and understand the coding, but that's where it ends. And I think that's the basic thing which I said yesterday. The challenges start afterwards. So if you are building your own company, or if you want to be a data engineer, what you have to first of all deal with data, where data is often not complete. And yesterday, I remember there was a question around incomplete data. So I'll try to answer some of those questions at some of those points in this talk. So when and again, these are all for my personal experiences. So it's not like I'm taking a third party source. So it is not a complete, comprehensive study of the literature, but this is all based on my experiences, and I'm just sharing my experiences. So of course you can say that there are some parts are missing, and that's possible because I haven't dealt with all of the algorithms or all of those ways to gather data. So when I had to, I always see there are basically two kinds of data that you have to require for your machine learning. One is a consumer data, and another is a business data. Now, in the consumer data, one side you have the likes of Google and Facebook who are, for whatever reasons, are using data often without you being aware of that your data is being used, and that creates a mistrust, and is not the right way to go ahead if we want to build products that people will use. So the right way, which I think the first thing, if you are looking to gather the data, is which I told you about this use case yesterday about my startup in Belgium. What we were doing was we had to train a machine to understand how people drive. Now, driving data, especially, is very confidential data, and especially in a country like Belgium, where people are very they value their privacy a lot. But what we saw that the first important thing of any gathering data is to incentivize the users. And when I say incentivizing the users to share the data, I really mean that in our case, what we did is we created this something called gamified the system. So we had things like goals and challenges, and then we provided some rewards. In turn, it was like that. We said if you drive, a goal would be to drive on a Friday evening and get a score over 9. And 9 was a score based on how you are driving. And if you score 9, then you get 20 points. And if you get, let's say, 30 points in total, you get a free coffee. And just creating gamified the whole system. And we saw that when you gamify and incentivize the users, and even as simple as giving a coffee, or even as simple as giving a movie ticket, people are very keen to share the data because they see immediate value. Of course, there's a bigger vision of improving the road safety and things, but people often don't connect to that kind of big vision. They like the big vision, but if I can incentivize them with small tokens, they like that. So then the first thing if you're collecting user data, you have to incentivize the users to give the data. Don't try to get the data like from hidden, which Facebooks and Google are doing in many ways. And that won't work, and I don't think that will be sustainable. And for a startup or a small business, that's like impossible. The second thing that I also say that you have to make the value very transparent. Now, this was I worked in Prague and on a smart metering project. So in a big energy company, and one of their they wanted to know what would make people adopt smart meters. And when we studied that their work and we spoke with people and studied different parts of the world, we saw that at the end, just having a smart meter in your room is not enough for people to adopt it. So typically, if you look at a lot of people, perhaps come from a background of IoT space, and in IoT has not been adopted that well. And one of the reasons that IoT has not been adopted in a consumer space because the value is not very transparent and not understandable to people. So if instead of showing to a smart meter kind of thing that what I consumed yesterday, that has almost no value for a consumer, you have to show what he could do to save more electricity, or what he could do to improve the environment, let's say. So the value has to be shown very transparent and understandable to an end user. So, and that would also give people to incentivize people to say, okay, I want to share the data. And the third thing that I also very much I've experienced and seen that is you have to educate your users. You cannot expect people to just give the data and you say, okay, I will give you a value, I'll give you some incentives, but you still have to educate them because most of the people do not have an idea about how the data is being used, what is being used for. So what we did, and this is a picture that what we did is we actually ended up sending physical letters. And it's just surprising to see in today's world, even when there are so many people who are full of online and Facebooks and LinkedIn and all those instant messaging, people still value a physical letter. And we did that. We sent it to around 400, 500 people, and the adoption was way higher. And we kind of trained them. We showed them, okay, this is what you could do. And they value it. They think that it's very personal. It's something that they like it. So So that's another lesson that I had learned, that if you want to get data from the user, you have to educate them. And educate them is not just about spamming them with an email or just or like, bursting them with some social media ads. It's more to build those personal connections. And we, in fact, even called people. So we send this post to around 500, 600 people, because at the early adopter market, we didn't need to have huge amount of people. But we had 500, 600 people. We called them, we sent them a post, and that increased people start using it. And of course, then when the early adopters adopt and start sharing the data, then the majority, the other people also start sharing the data. So I think what we had seen that by doing these simple three things, that incentivize your users, make the value transparent, and educate your users, you would be able to way more improve your chances of gathering the user data. The next thing about in many cases, we are talking about business data, right? So unlike in a consumer data where the protections are very high, and specifically in Europe, where because of GDPR, that it's not only storing but also gathering the data has to be consent. But that's true everywhere in the world. But of course, most companies do not follow that. Like in countries like in India, I'm pretty sure that most companies don't even follow those kind of consent so much. But there are very strict laws around in Europe and to some extent in the States. So I think that's consumer data. But in the business data, the regulations are much less. Because businesses are not considered as private entity. Unlike in the US, there's some aspect of that, but in Europe, normally, or in other parts of the world, majority of the world do not consider businesses as being a private data. And most of the data in business data is actually publicly available. So what, I'll give you an example. One of the systems that I'm building now is basically a sales prospecting tool. Is how do a company identify its next customer? So this is what we are trying to build. And to identify the next customer, we need data from the user, right? Or we need data from the business. So the next customer is a business, not a person. So we need to collect data about the business. And what we had wanted to originally do is to train a classifier, neural network classifier with input data, and then basically classify them into three different kinds of groups of quality of a prospect or a lead in the sales. Is either is high quality, low quality, or medium quality prospect. Now, what we are looking at, what kind of features that we are trying to extract is we are trying to understand four questions, like who is your best customer in terms of customer size, decision maker, why they became your customer, why they still buy from you. So there are these different parameters that we want to collect from different businesses. Now, of course, not all the data is available. And even publicly. So, for example, some of the cases, like I told that there are three major ways of getting those data about businesses. First is a web scraping. So, where you can scrap, let's say number of employees is one such data. Now, we are using LinkedIn, and kind of we can scrap data in the LinkedIn, and we know, okay, X number of employees are in this company. It's not completely accurate, but to some extent. So that's one kind of way we can collect the data. Web scraping also helps us to scrap data about, let's say, the address of the company, about other things like whether the company is of what is the category. So we are looking for in the text in the website of the company is what are they are about. What is this company doing? We also are trying to do another thing, something called sentiment analysis. I perhaps will talk about it. Sentiment analysis is basically we want to see. For a tourism company, we are trying to see that whether in a given country there is a high good sentiment about tourists coming to that country from a given part of the world. So we are also analyzing the text in the newspapers of that particular country and trying to understand the sentiment. So we are doing these different kinds of things to gather the data from a pure web scraping way. So this is kind of something I'll go through some examples later on, but for example, this is some of the data that we collect via pure web scraping, right? So these are the names and this industry, the sizes we are also gathering from the LinkedIn, the website, there are some notes, LinkedIn. So we are collecting this kind of data purely through the web scraping. And in this case, for example, I kind of give this example of the hotel tourism case where we want to collect the data, size of the country, designation of the decision maker, sentiment in the country. So the sentiment, the country, and the size, and the kind of category is all through web scraping. But let's say these are some of the data that I show you that we are collecting. we also want to know who are the decision makers, and that also we are trying to collect through the web scraping is, okay, who are the people in different countries, what is the size of the company, and we are using certain rule-based systems also to try to identify that, okay, in this kind of country, this is a decision maker. So this is all different types of things that we are collecting, and these are not so important for now. Like these are basically the different kinds of data we are collecting, that how we are collecting the data. And then basically one of the things that when you collect the data, you often see that, because yesterday one of the guy asked was, what about incomplete data, or if you don't have enough data? So we, for example, in this case, we collected the data about size of the companies, and we saw that there is a high weight, now too many companies of large enterprises and medium-sized enterprises, as you can see, and too less of companies of small enterprises. So our source of the data was somehow skewed. So what we did is we said, okay, instead of categorizing in 3 different or 4 different categories, we ended up categorizing them into 2 basically types: large and small medium enterprises. So these are the kind of challenges that you would face, that when you collect the data, often you would not have data across all the 4 categories, types of data, as an equal number of things. So some of them will be high, some of them will be low. So then we have to somehow change the model or adapt the model. So these are the challenges that you will face while building those things. The second thing that we had was the second way you can gather data is which you cannot find through web scraping. Now, I use a word called marketing techniques to gather data. So let me explain you this a bit. So there was a use case where one of the company who wanted to gather data about which companies are moving. So for them, they want to know that what are the companies that are moving their offices, because when a company moves an office, there is a high propensity to buy new stuff. And it's an information that is very difficult to get. No company in the web will announce that, oh, we are moving offices. I mean, that's not normally they do. And only after they move the office, they may change the address. But that's already too late because they already have moved. So in those cases, it's hard to get the data through pure web scraping. So what we ended up doing is basically running a marketing campaign. So instead of, what we did is we run a campaign saying, hey, if you are moving your office, we will give you a free token, or like $10 or $20, $50 voucher or something like that. And we collected the data and about types of companies and what are their what are they trying to, what are the features that they will have when they are thinking about moving, and then we try to train a model. So the second way of collecting data would be where you are incentivizing them to share the data, like what we did for the consumer. We are also doing that for businesses, to incentivize them, give a small incentivize to share the data so that we would know who are moving the offices, and then we can train a model based on that. And the third one is models where there are incomplete data, or where we are not able to even find a way to get the data. And this is an example I will give you, is it's a category of a company. In one of the slides, I told you that we are collecting the data like this kind of categories from LinkedIn, right? But LinkedIn doesn't provide that granular level of category. So in our case, we had to have a category of wedding planners, hotels, tourism organizations, much granular types of category rather than just companies in tourism sector. So often LinkedIn would provide us with this category. So web scraping does provide, to some extent, that in their website we go and we do look at the keywords, and that's one way of doing it. The other way of doing it is trying to find other models that we can use to identify the category of the company. I don't know how many of you know LSTM, but LSTM is, as I was saying, is basically trains over the like a sequence of events, a sequence of words, or a sequence where there's a sequence. You train a machine to where the data has where the order of something happening is important. So what we did is we trained an LSTM with the name of the company. Now, the order in which the words appear in the name, we saw ended up quite well defining the category of the company. And in a way, you can intuitively understand that makes sense, because when there is the name that most companies would think putting a name would be which is self-explanatory. But of course, I know most tech companies don't do that. So this is not working on tech companies. But when we're looking at non-tech sectors, like traditional sectors, most companies put their name, which is explains the what they are doing quite well. And in that category of the case in tourism sector, it actually worked decently well. So what we so these are the three different ways of we can gather the data, and we can get data from other places. Now I will give you one more example about where we don't have a data. So I told you another use case yesterday about the solar project, right? And I couldn't show the video, and I hope today I can show the video. Let's see if it works. No, it still doesn't work. I cannot click on it. So basically, what we are doing is we are using the community to gather the data. So we are not incentivizing people through giving a free, coffee or something, but we are saying that there is a bigger cause. So it still ends up incentivizing, but our data, people who are gathering the data, are not our users. And this is something we are trying to do is we are just getting some people who are not necessarily our users, but trying to create a community saying, oh, this is a social good, and come and help us build the data. Because there is no such data. And that works in kind of more social projects like this in the solar, but not in the cases like where it's pure corporate data. So that will not be possible. So depending on what kind of category you are in and what kind of data you want to do, you can employ one of those 5 or 6 methods I said, and you can see which one makes sense to do. So that's part of the data gathering part, right? The second thing that I want to talk about is when you're actually building a system, one of the challenge comes with architecture. Now, often a lot of this machine learning is generating a lot of data. Not every use case, but many use cases. And what you end up doing is having creating two kinds of databases, because one is your traditional database, which is a SQL-based database, where you have, let's say, a lot of data from the past, which is relational data, right? But then in the new part, where you're actually collecting all the data about users, driving, whatever you are doing, it's often a time series data or a big data. And so you cannot use a traditional database that you had been using, or banks or things have been using. So you ended up creating a new database, which is basically big data database, which is no SQL database, let's say. And what you have to then do is create an application logic which combines the two different kinds of databases into one place, because you are getting two different data. Now, this is a challenge because often writing this piece of code in the application logic of combining two databases is not very trivial. And a lot of companies, when you end up working in a real world scenario, you don't see these kind of problems, because most of the AI machine learning are done in a proof of concept level where they don't care about combining with the real world data. So there is no SQL data. Most real world data is in SQL. And now when we're talking about the new data, then you have to combine and write a piece of code about it. I had the opportunity to work with a company based in Newark, and what they were doing, they did solve this problem in a very neat way, in a way that they created a new database called Timescale DB, which was a database which is a NoSQL, which is a big data or it's a time series data for SQL. So it is using SQL. So it still stores the data in SQL, but which has the features of a big data. So so when you are querying or millions of rows, the performance doesn't go down. So there are companies like that, as I said, I worked with one of them last year, who are trying to solve this kind of problems in a neat way. But normally you would face this kind of problem when you are dealing with some like machine learning and trying to adapt building the real world product where your data comes from different sources and of different types. And then finally, I want to talk about one thing about the design thing. And I often say that, pick the simplest, best fit algorithms. And I know there is maybe a lot of that you guys are technical, and there is a very desire of technical people, having myself being an engineer, to pick the most complicated algorithm. We want to show that we are doing some crazy shit and very difficult kind of algorithms, and these are most algorithms and most problems in the real world are actually very simple. You don't need to know much complicated. You don't need a deep learning. I can assure you that deep learning is hardly used in real world cases. Well, I'm not talking about autonomous vehicles, but I'm talking about most real world cases. It ends up being classification, clustering, maybe k-means, a simple classifier, word to vec, like basically very simple algorithm. That's why I keep on saying that most real world cases doesn't require a rocket data scientist, even doesn't require, forget a PhD, doesn't require even a master's degree. I mean, most of these problems could be solved by people with like a month's, or even a few weeks of just some education or training. And so that's why when people say, we want to be trained as a data scientist, I often think that I don't think majority of the work would require that. I think the challenge is not around how to code or like which one. The majority of the problems are simple algorithms, but the problem comes to how do you gather the data, how do you deal with the data, incomplete data, from where or which algorithm to use. So this kind of structural thinking would really help when you're trying to build some real world products. And I've just listed here like few of those neural network algorithms, and these are as simple as what we can achieve. And I briefly talked about it yesterday too. And finally, this is something very close to me, and as we see that still one of the biggest challenges is data, and we talk about architecture, we talk about algorithm, but the biggest challenge is still manpower. The manpower is because it's very expensive to hire PhD level. But again, most people don't need a PhD, but they still end up hiring a PhD data engineer. So I've seen so many times that companies hiring data engineers who are spending 90% or 70% of their time not doing data science work. They're doing the basic stuff, but they still hire these people at a very high cost. And this makes a lot of smaller companies not able to hire data scientists. What I'm trying to build, and I think that's where the future would be, which is where it's not anymore like an expert data scientist will be required to solve majority of the problem, where a community will come together and solve the problems. And since data science and machine learning is becoming a commodity, because it is as simple as writing 10 lines of code and you can write a classifier, what would happen that communities of students will come together and solve problems. And we are using that in the solar project, which is a fairly complex machine learning problem to solve, given it's using a CNN. We are using a group of 50 students who are working on building the solution, and we have extremely good results, which I briefly talked about yesterday. We are using complex machine learning architectures like UNet, semantic, UNet and mask RCNN. But yet these are the students who are working for solving these problems. And I see that's the future of machine learning, going to be solving real world problems where communities come together based on certain protocols. I've written down those protocols in the right-hand side where you can show that we are using GitHub, we are using some, I use the word smart contracts, but of course in future the blockchain would come in, but for now we're just using some kind of contracts between, not a smart contract in blockchain terms, but in terms of protocols and processes that we are following, where students are coming together and then building a product together and the community is coming together. And this is the way I feel that the future of overcoming challenges with programming will come. I wrote some of my thoughts around this in this article called The Potential of Communities and Machine Learning for Good. And this is also a medium, but also it came out in Open Data Science Conference. There's a blog for that. And feel free to read it if you guys are interested about where I see the future of product building will go. And yeah, I think that's all for today. I wanted to talk about. I would be happy to take your questions. Let me just go back to the screen. I'm sorry. And yeah, I don't know if you have any questions, but. How are you ensuring you are not overfitting with a model? Well, as I said, there are ways to drop out is one of the methods to do or not to ensure using overfitting with a model. So if we are overfitting the model, then we try to use the dropout. These are standard techniques that are being written down to make sure that you are not overfitting the model. So you can read about dropout. I mean, that's a standard procedure. So, I mean, I can go and explain that, but as I said to you yesterday also, that I don't want to go give a technical talk here. If there is an interest, I'm happy to go into some of this technical mathematical talk, but then for that, I will always recommend you guys to go and do a course of Andrew Ng, because he talks about those things very well. Like, how do you drop out works? How do you stop overfitting? How do you deal with those mathematical things of that? So yeah, I think it seems there are no more questions. I hope it gave you guys some ideas about how do you deal with this kind of problems where you have to gather data, and what kind of data, and how do you get those data? How do you architect the system? And also, I'm sorry, there's too much of sun here. and also how can the future of product building would be, where companies, how they would be solving these problems. I don't know how many of you are entrepreneurs, but this is primarily interesting for very entrepreneurs and small businesses to see, okay, how can I reduce the cost of development from a machine learning point of view, and how do we build the products? So that's from my side. I think feel free to, if you guys have any follow-up questions, feel free to ask me and add me on LinkedIn. I'm there and happy to answer any of further questions. Okay, I see another question. Are data mining, statistical analysis, and machine learning similar? Program themselves. Data mining is basically, we are trying to, there is no learning in data mining. So difference between a data mining and a machine learning is, in a machine learning, you could use certain principles and algorithms from data mining, but that is just part one of it. And then you machine learning algorithms and deal with that and try to learn something. So that's a difference between not a difference, but you can say that data mining is basically mining the data, trying to understand the thing, and machine learning is also doing some learning. Yeah, it's just too much of sun here, so that's why I moved it, because it's like the sun is falling on my face. And then there's a question about statistical analysis. So statistical, you could use, again, there are machine learning algorithms, you could use regression techniques, naive-based, which comes from a statistical background in machine learning. These are not mutually exclusive kind of things. So machine learning algorithms could use aspects from data mining, from statistical analysis, but it goes further by saying, there is an aspect of learning also there. On the other hand side, there are things like neural networks, which is not based on, let's say, either data mining or statistical analysis. So there are different machine learning algorithms. Some of those algorithms have backgrounds or take concepts from data mining. For example, I'll give you example, self-organizing maps. Well, self-organizing maps, not really, sorry. K-means would be coming somewhat from a data mining background. K-means typically comes from a data mining aspect, or let's say naive-based or regression are from statistical. On the other hand side, neural networks are not from that. So it's kind of depends on what kind of machine learning algorithms are there. Do program themselves? No, they don't program themselves. And I remember yesterday there was a question about meta learning, and I said I will check it out, because I've never heard the word, and I checked meta learning. It's not a well-defined term, it seems. What it says that these are learning that can learn by themselves. The bottom line, despite all the hype around AI being saying, oh, these are self-learning algorithms, this and this, unfortunately, they are all not true, if I just be polite. Machine learning algorithms are simple as learning patterns in the data. If that's all it is. They just learn patterns in the data. And now, why is that useful? Because there is a pattern in everything that we do. So if I have to explain in machine learning, what is machine learning in one line, that's learning patterns in data. They don't learn by themselves. There is an algorithm. There is a way to learn those things based on the previous data. But the learning is basically learning the patterns. Well, that's typically what I would say. So I don't know when you say program themselves. No, you have to program, right? And someone has to write it. But of course, there are libraries and things like that. So machine learning in traditional computer programming. Well, again, coming back to the same point, your computer program could be doing many things. You could write a code to do 2 + 2 = 4, or you can write a code to do deterministic things. There is no learning in that. Machine learning is trying to a program which is trying to learn patterns in the data that you have and try to learn that pattern. So that's the difference. And programming is, again, bigger space. You can use programming for various purposes, various reasons, often deterministic, which is non-learning thing. and machine learning is more into the learning aspect. To what extent can machines really understand the world? I don't really understand what you are trying to explain, but let me give you an example about knowledge representation. So I was working in a, I think perhaps I understand what you're asking me. So for a machine to understand the world, you have to represent the knowledge in a data form which is understandable to machines. And yesterday I did speak about things like intuitive patterns and quantifiable patterns. So there are patterns in the world, and there are some patterns are quantifiable. That means you can have data about it, you can store data about it, and those machines can learn from those data. But a lot of the data, a lot of the patterns are intuitive. Like we follow intuition. Like perhaps there is a very interesting example of wisdom of the crowd. Let's say I give you an example, wisdom of the crowd, which is basically, there was this experiment done in, I think, 1906 or something, where they put a ox in front of 100 or 500 people, and people were asked to guess the weight of the ox. And what they found out, that the average of all the people that they guessed is very similar, almost like 1 kilo, difference of 1 kilo with actual weight of the ox. Now, think, what is that? How are we behaving that? So our intelligence is not just about quantifiable. These kind of things are not quantifiable. You cannot, this is very intuitive aspects. So if we have to model that kind of knowledge for machines, we don't know how to model it. We don't know how to represent that kind of knowledge. So we can only represent a knowledge which is quantifiable in a form of a data understood by machines. So if your question is to what extent machines can really understand the world, it can understand to the world to the respect to point where you can represent that knowledge. Anything beyond that is not understandable to the machine, of course. And once you can represent the knowledge, it is understandable. You can create logic. There are different ways to understand. So I worked in the past. I worked in the topic called logic. So we were trying to represent the world in logical languages: first order logic, second order logic, third order logic. These are logical systems. So which is trying to kind of if then else, but in a way of logical system, not through data. So in AI, there are different ways you can use represent the knowledge too. In AI, you could use like a machine learning algorithm, which is purely data. You're not trying to explicitly represent the knowledge. You're just storing the data and trying to find patterns in the data. On the other hand side, you can try to represent the knowledge in a formal language, like a first order logic or a second order logic, which is not dealing with the data, but you're actually representing the knowledge. And in some cases, that both you can combine both of them, because many times you cannot store or have data for everything that you have. Because you may not have data for many things. You may have data for a few things, but many things you don't have data. Then you need a formal language to represent that kind of knowledge. So these are the different ways you could represent knowledge. But it all comes down to basically limitations of being represented the knowledge in the world. How are artificial intelligence and machine learning different? I think I answered that question. AI is a bigger set of algorithms, which is trying to, again, the definition of AI is, again, a very vague. Different people will define different ways. So 1950s, I think Turing defined a test called Turing test, where he defined an AI is something called, you have two rooms, there's a machine and there's a human, and there's a third person. He would not be able to differentiate between chatting with a machine or a human. So for him, he would not know which one is machine and which one is human. That's for him as defined as a Turing test of AI. But and other people have defined AI in a different way, intelligent machines. And what is intelligence? So that it's a vague term. But if I had to define what is an AI, I would say that machines which has an ability to somewhat learn, basically, that's to me is an AI. And machine learning is where you are learning from the data. So the learning is learning patterns in the data. So that's specifically within a space of data and learning. AI could be on a bigger space, which is learning from knowledge, learning from other aspects, not necessarily only from the data. What are some difference between a linked list and an array? I will skip that question because I think that this is I think you are asking a Python question, right? And I would not answer a Python question, and because it's not for a Python course. But you can easily look this up. What evaluation approaches would you work to gauge the effectiveness of machine learning model? What evaluation approaches would you work to gauge the effectiveness of machine learning of model? Well, I think well, I mean, ultimately, whenever I'm building a system, what really matters is when we are not running on a test case, but on a real world data, right? So that is the ultimate evaluation. So people would define that when you are training, let's say in a supervised learning, when you're training a machine, you have a training data, you have a test data, and then you have real world data. Ultimately, you can perform very well in a test data and a training data, but on a real world scenario or a real data, it doesn't end up working. So ultimately, it comes down to how well your machine models are performing in a real world data and making those either predictions or trying to whatever you're trying to do. But let's say you're trying to do prediction, then how well the predictions are. That would be my. Should I worry about machines stealing our jobs? Well, again, no, not really, because I wrote it in the book that machines we are overthinking about the power of machines. The machine algorithms that we are talking about have what they are is finding patterns in the data that humans are not good at. So machine learning has a huge opportunity to solve problems that humans are not able to solve. So there is a term called augmented intelligence, and I believe in that, which is basically machines will augment human intelligence. So humans are good at doing certain things, and I don't have the slide here, but I wrote in the book is humans are good doing at certain things, and machines are good doing at certain things. What we need to do is bring these things together. So if you are talking about the future jobs, where your focus should be is where machines where as a human, your role in the job is based on intuition, emotions, which are unquantifiable data, while the machines are good at doing the quantifiable data. So if your work is a routine, boring work, doing the basic things over and over again, then machines would take over the job, obviously. And I think they should take over the job because humans are not good at doing those things. But if your job requires thinking, intuition, emotions, connection with people, then no, they will not be taken, and more jobs will be in that space. So that's how the job scene would be. So I don't think you should be worried about job if you are dealing with those. So that's why when people talk about the next big thing will be data science and engineers, I actually do not agree with that. I think that machines will take over those writing code. I mean, they are already doing that. Machines are already writing code, and I think that machines will end up writing piece of code very well, much better than humans can write code. But what machines cannot do is product thinking, like what I'm talking about. How do you gather data, thinking about what algorithms to use, where to use it. So this kind of constructive thinking, which requires much more sophisticated intelligence than just writing a piece of code, will be required, but machines will not be taking over. So just have to be careful with what kind of job you're talking about and what machines can do. How about I deal with how about the imbalanced data set? So, I mean, there are different ways we deal with. I'm not sure exactly when you say imbalance, what exactly you mean by imbalance. I don't see it. I don't think that's a term that I have came across as a word. But if you are talking about incomplete data set, then what we try to do, there is no standard answer to that. As I said, I go through these three examples that if often it will be incomplete data. So either we try to get the data from the web scraping. If we cannot get the data from web scraping, we try to find alternative machine models. So in some cases, we say, okay, maybe we don't get the data. Can we train other models and see whether that would work? So I'll give you another example. Is today, in fact, today I was talking with this one of the company that we are trying to build is trying to find a next customer, and we wanted to know the behavior of a customer, let's say, but we don't know the data, right? But then what we kind of saw that the address, I'm not going into too much details, but the address of the person would define certain behavior patterns. Because where we live in many parts of the world defines our income level, defines our education level, defines our, not behavior in a way, but let's say the purchasing power. So just based on an address, so these kind of things then we have to come up with thinking, maybe instead of actually getting the data based on the behavior, which we would not have, but we can just use the address as being an indicator of that data. So these kind of structural way of thinking would help you to get over the incomplete data.
Thanks for the wonderful session. Actually, it's very, very informative and useful for us. And I guess yesterday I have asked you one questions about what is meta learning in machine learning. You have answered for the question also. Thank you so much. And I have one more questions to ask to you. How can you use your machine learning skills to generate revenue?
So what I wrote in the book, and what I really see is that there is a lot of processes in the world that are broken. And I'll give you one example from that. And there is no standard answer to that question, but let me give you one example. So let's say a bank. There is a bank, and typically a bank, let's say in a country like Vietnam or in other parts, there is 70% of the people don't have a bank account. So traditionally, the banks never catered to those group of people who don't have a bank account or giving them loans. And these people would go out in private, in a black market, and take loans from individuals at the rate or interest rate of 80 to 100% interest rate. Now, banks can use machine learning algorithms to identify the risk, much better risk factor of those people, right? So they can assess the risk on a much level rather than just relying on a bank statement. So they can use the education qualification, the address, the age, the parents, different parameters to define the way to define the risk of someone returning the loans rather than just seeing a statement. Now, because of that, they can cater to a large number of the population who they were not in the past catering to. So that would be one way of generating revenue. The other examples, there's so many examples I can talk about. Let's say an insurance company. Typically, insurance companies do not make any money from business deals because the premiums that they calculate are based on a very old-fashioned, static data. Now, with the machine learning, they can actually create the premiums in a very dynamic way. So they can every year they can see how many employees the company is growing, how the company is growing, what are they doing, and they can define the new premiums based on that, which is very dynamic. And in that way, they will increase revenues a lot more. Because instead of using old-fashioned static, which is once in 10 years they make, now they are doing this in dynamic. In healthcare, you can cater to much bigger audience by giving a remote kind of diagnosis, which is catering to a large number of population who are not perhaps able to visit a doctor every, and standing in a queue or maybe quite expensive for them to get to that kind of medical attention. So there are in every sector that you look at, today's world, they are all kind of broken systems. I use the word broken systems because they all were made to cater to human limitations of human mind. And machine learning can provide in a way to provide in better services or to reach to an audience that they were not able to do or create new services. And that would increase the revenue. So that's the way to look at that's why I use the word value rather than ROI. So when I go to talk to banks, so like as I said, last week I was in Kuwait and the bank said, hey, how could we, what is the ROI? And I said, if you are looking from a pure return of investment in a monetary way, yes, you would not perhaps be able to see the ROI. But if you're looking at the ROI from a user engagement point of view, creating new value, solving different problems, that would increase the revenue in a mid to long term because you are then providing value to your customers. So that's the way to look at generating revenue using machine learning.
Thank you so much, Rudra, for the wonderful answer. And today's session you have discussed about data gathering and overcoming challenges with data gathering and programming. I have one few questions. The thing is that if I have challenges in data gathering or in programming, can you give me some tips to overcome from that?
So I think in a very simple terms, if I say that the key would be to select the simplest model. Rather than making a complex model, start with the simplest model. And start with the minimum data that is required to build such a simple model. And once you can get that model right, then think about what extra you can add on top of that model and how can you get the extra data. So I gave you the example of web scraping. It could be via creating other models, or alternative models, or through marketing techniques, or by incentivizing users by getting their data. But to start with, you start with a simple model, and simple model often doesn't require a lot of data. So, which is the basic, not a lot of data, but it may require a lot of data, but it may not require a range of different kinds of data. So that would be my basic, simple answer to that question.
Thank you so much, Rudra. And thanks for your precious time you are spending with us. The session was so informative and useful for us.
Oh, I'm happy.
We are awaiting to see you at next time.
Oh, thanks a lot. Thanks a lot. I hope you guys found it useful. Thanks.